The phrase deep clean is often used in the context of vacuuming carpets, implying the cleaning is somehow more thorough. This short video will discuss what is practically meant by deep cleaning and the factors relevant for particle removal from carpets. I'll also explain why watts and other metrics are misleading and reflect on informal internet tests. A vacuum cleaner creates a differential pressure between the floor head and the surface it's in contact with. This causes air to flow into the head through the fibres of the carpet. Particles can be accelerated by the moving air and enter the cleaner head. Particles can become trapped by the complex network of interwoven fibres. They may also fail to be removed if they aren't accelerated enough to be drawn in whilst the head is over them, either because the suction head isn't over them for long enough if vacuuming too quickly, or if the resulting airspeed isn't fast enough to accelerate sufficiently, which can be worsened if the particles are very heavy or aerodynamic, like rice. Many factors result in effective particle removal from carpets. As air moves past particles, they experience a force and are thus accelerated in the direction of the flow. The faster the air is moving, the more force they experience and the more likely they are to be removed. The resulting airspeed experienced by particles in the carpet is the most important aerodynamic factor in effective particle removal. The experienced airspeed will vary widely depending on location within the carpet and the associated local resistances. Air current, sometimes measured in cubic feet per minute, is a measure of how much air is being drawn into the vacuum, but it doesn't necessarily directly equate to air speed experienced by particles in the carpet under the head. This is for two reasons. Firstly, gaps between the floor head and the carpet can cause a suction leak. There can still be high airflow, but much of that air wastefully bypasses the carpet entirely and isn't involved in particle removal, leading to low resulting airspeed through the pile. Secondly, with a good seal to the floor, the carpet itself acts like a filter and resists air motion. This reduces net airflow relative to the head being off the floor or through the open hose. Carpets with denser piles will restrict airflow more. Motors are designed to be strong and compensate for this resistance, ensuring sufficient air speed through the carpet to remove particles, despite reduced relative air current and flow. Therefore, measuring airflow from a vacuum's hose is very misleading because this doesn't consider how that air current actually translates into air speed as experienced by dirt through an air-resistant carpet at the cleaner head. The ultimate vacuum strength of a motor, sometimes measured in inches of water and wrongly referred to as suction, represents the maximum vacuum pressure a motor can pull under maximum resistive load. Like with airflow, or air current, the ultimate vacuum strength doesn't directly indicate the resulting air speed a cleaner will produce within a given carpet where it counts. Additionally, if a vacuum suction is too strong, for example, if the ultimate vacuum strength of a motor is too high, then the head, with good contact, can clamp very hard on the floor, making it difficult to move. Again, the air speed experienced by loose particles is the most important factor in effective particle removal. There's a wide range of particle sizes, and not all particles are loose. Particles not on the surface that are deeper in the pile can be trapped in two main ways. They can be netted by the complex network of fibres as they're accelerated upwards in the flow and hit an effective ceiling. Or they can be wedged firmly between grippy fibres deep down. Likelihood depends on volumetric fibre density and their material, which determines the coefficient of friction. To loosen particles, good vacuum cleaners agitate a pile. This is achieved in two main ways. The moving head separates the pile, opening up gaps, dislodging netted particles, and can reduce particle gripping. Secondly, as the brush bar bristles, or equivalent, strike the surface, the mechanical impulse can also help dislodge particles. Vibration affects dense particles more, like sand or salt, which generally move upwards with the flow under the head. This vibration has little effect on particles more harmful to health, like dust. I've produced a video with a link in the description explaining why excessive vibration outside the cleaner head isn't beneficial. The brush bar can also directly grab loose grippy particles off the surface, such as hair. So, to achieve good cleaning, particles need to experience a high air speed and be free to accelerate in the flow. The size and weight range of particles in a carpet is large, and removal is statistical, as discussed in a video with the second link in the description. 100% removal will never happen, even with the best vacuum in the world. Some will always stay trapped, and there will always be dust in a carpet. Neither airflow or air speed can be measured from the hose and must be measured within the pile, which is extremely difficult. As such, air watts are often used to measure the average air power through a pile at the cleaner head, but are misleadingly used as a measure of vacuum performance. It's doubly confusing because there are different measures of air watts. There are motor air watts, which is the maximum power a motor can deliver, and the resultant air watts at the cleaner head, which is usually the quoted value. That air power is distributed across the head opening, which can vary in size between cleaners. The air power per unit area, i.e. air flux density, is a better normalised unit that takes head size into consideration. However, even this isn't really useful because air watt measurements don't take into account everything else that happens in the presence of an air-resisting carpet. Doubling air flux density doesn't necessarily double air speed experienced by particles, owing to turbulence and other complex fluid dynamics. This can be seen by performing international industry standard tests, which show the highest average cleaning performance across all floor types can be achieved by cleaners with relatively fewer air watts, if all of the factors are optimised to give high air speed and optimal particle loosening. Air watts are thus misleading if used to try and judge how good a vacuum cleaner is, and they should really stop being officially marketed. Only average cleaning performance across all floor types, as measured by international industry standard fair and comparative testing, should be used to measure how good a vacuum cleaner is. A single, simple metric anyone can understand. Carpet fibres are densely packed at the surface, and it's very difficult to open them by walking on a carpet. Putting weight on a carpet in fact crushes the pile, squashing out any internal gaps. Particles generally don't propagate to the base of the carpet between regular cleans because there are too many fibres blocking their way and acting like a filter. It's a myth that in normal living, significant dirt is deeper than the surface region. The surface is also where dust can be interacted with and get lofted back into the air where it can be dangerous to health. How well a vacuum cleans the upper region is most important. If carpets are neglected and dirt gradually accumulates at depth, it's unlikely the deeper dirt will ever naturally return to the surface and be a risk to health. Sometimes you'll hear the marketing myth that dirt, sand in particular, near the base of a carpet, is harmful to the carpet and needs to be extracted. This is misleading for two reasons. Firstly, as mentioned, significant quantities of larger sand-like particles don't naturally get to the base of a carpet in normal living with regular cleaning. Secondly, as the carpet is stood on and compressed, sand particles at depth move with the fibres, meaning they don't scrape or abrade. Sand on the surface, however, can be scraped across the surface, causing sandpaper-like abrasion and damage. The concept of a deep clean is a marketing myth, portraying both an unrealistically high concentration of dirt at the base of a carpet under real-world conditions, and implying it's harmful to health and the carpet. This is false, and there is no formal objective evidence for it. Meaningfully, a deep clean is achieved by reducing the concentration of dirt in the more important surface region of carpets, where it mostly resides and could be interacted with to cause harm to health or the carpet. Whenever you hear the term deep clean from now on, understand it to mean deep into the upper region where almost all the harmful dirt is. An important takeaway message from this video is that in general, more power in any vacuum only allows rarely encountered larger spot messes to be cleaned more quickly. It doesn't mean, for normal mess levels where dirt concentration is relatively low, that more powerful cleaners can also reduce the concentration of dirt in the surface region lower than a less powerful cleaner. That requires more than just brute force and needs very careful engineering to ensure dirt experiences a high airspeed through the pile under the cleaner head after it's been optimally freed. The statistics of particle removal from carpets is covered in detail in the video with the second link in the description, which I highly recommend watching to appreciate this point. It's a complete myth that you can't achieve the lowest concentrations of dirt by using only low power levels in normal, real-world mess levels where there's less dirt to start with that's harder to extract. The disbelief of this admittedly unintuitive point can be seen by the difficulty in accepting that the latest highly engineered cordless handhelds intended to replace brute force mains-powered units can still achieve deep cleaning, despite relatively smaller numbers on paper. They actually can, as nicely shown from a test in my Dyson V10 review video, with the fourth link in the description starting at 27 minutes in. You can also see this here. My deep pile carpet is many years old and cleaned recently only using the V10 handheld cleaner in either only mode 1 or 2. These modes will show very low airflow numbers at the hose, as discussed earlier, and use less than 30 air watts. Yet, at the deepest levels, there is no sand or dust at the base, even in the most heavily used areas near the door where gritty, sand-like dirt is walked in frequently. Highly refined engineering utilising very little power absolutely works just as well as the most overpowered brute force machines, but with huge benefits in practicality, efficiency, and environmental impact. The evidence is right here under real-world usage. Old-fashioned or industrial cleaners can be overpowered, with the cost of over-engineering, inefficiency, and excessive adverse impact on the environment. And while may be able to clean unrealistically heavy messes quickly, they're not necessarily able to achieve the lowest dirt concentrations for normal dirt levels. Industry standard test data is never provided for such machines to provide fair comparison. The second half of this video will address measurements and tests that are commonly seen on the internet and YouTube. These try to convey the effectiveness of a vacuum cleaner, but are in fact very misleading. The flour under the rug test involves putting flour under the backing material of a carpet and seeing if a vacuum can suck it through. A reasonable test of brute power at first glance, but highly misleading if used to demonstrate cleaning performance. Some carpets have backing material that's airtight, preventing anything penetrating through. Some carpets are even on top of thick underlay. Large amounts of dirt don't naturally get that deep through a responsibly maintained carpet, let alone through the backing material, making the test completely unrepresentative of real-world living. Dirt under a laid carpet is also completely harmless, would never interact with people, and is best left alone. Bringing that dirt, which wasn't introduced during normal living, up through the backing material increases the amount of dirt deep in the carpet. The statistical nature of particle removal will make it difficult to fully remove, and some will always remain in there, meaning this test will actually pollute a carpet by bringing dirt from a region where it's harmless into the surface region where it can be harmful. Vacuums which can bring dirt up from beneath the carpet backing and into the pile are not necessarily the best at reducing concentrations of that dirt to the lowest levels in the upper regions where it's important to do so, again due to the statistical nature of particle removal from carpets, as discussed in the video with the second link in the description. You need more than brute force to reduce dirt concentrations to the lowest levels. The best performing vacuums can remove the most dirt from carpets in the upper region where it is genuinely harmful, including the small quantities of deeper down dirt, and without reintroducing dirt which was never introduced in normal living. The test is very misleading at best and carpet polluting at worst. The sand in the carpet test involves intentionally inserting very large concentrations of sand deep into the carpet and within the pile, and crudely attempting to measure how much is removed after vacuuming. Again, at first glance, it seems like a good test of a vacuum's ability, but again, it's completely misleading with more careful thought and understanding. The sand is artificially combed and forced down into the carpet. It's packed deep between the dense fibres and at the base. This is completely unrepresentative of real-world conditions, and the carpet would never naturally get so sandy at that level with responsible housekeeping. No cleaner ever removes all the sand from such absurd tests, and some is continually removed afterwards, but this is rarely shown. And this is due to the statistical nature of particle removal, again as discussed in the video with the second link in the description. Again, it's incorrect to conclude that cleaners which can remove dirt from a large mess, where it's easy, can perform as well with a lesser normal mess, where it's much harder. Using only sand is also misleading because it neglects other types of dirt, much of which is actually harmful to health, unlike sand. I've already covered why naturally occurring concentrations of sand deep down isn't harmful to the carpet, and why it's important to remove it from the surface region only. The sand in the carpet test is thus highly misleading and indicates nothing of real-world significance about the performance of any vacuum. Both airflow and suction tests, suction being an incorrect term for ultimate vacuum strength, try to indicate the power of a vacuum and therefore imply its cleaning effectiveness. This is done by measuring both the airflow and ultimate vacuum strength at the end of the hose. As discussed earlier, this is highly misleading because it makes several incorrect assumptions, namely that the same airflow is maintained at the head when clamped to an air-resistive carpet, which it isn't, that there are no air leaks at the head, that these metrics directly translate to airspeed experienced by particles through the pile, which they don't due to complex fluid dynamics. It also ignores all other factors necessary to dislodge trapped particles from fibres. Sometimes misleading attempts to portray the quality of a vacuum are made by seeing how far away dust can be sucked into a hose, implying better carpet cleaning performance is achieved if dust can be sucked from further away from the hose. Ultimately, any measurement of airflow at the hose simply represents the airflow at the hose, and any suggestions it translates to what happens at the cleaner head or can be used to judge the cleaning performance of the machine are complete nonsense and illustrate a lack of understanding of fluid dynamics. Big mess tests involve an absurdly exaggerated and unrepresentative amount of dirt being laid out on a carpet to see whether the vacuum copes with cleaning it. When it's not portrayed as pure visual entertainment and is used to draw any conclusions about performance, then this becomes highly misleading. This is covered in detail in the associated video with the third link in the description. But briefly, the problems are that this level of dirt is never encountered in a home. Vacuums are not tuned for performance for these mess levels. As discussed earlier, if a vacuum can cope with cleaning easily accessible excess dirt, they might not clean as well with more normal levels, which are harder to extract statistically and require clever engineering rather than just brute force. Vacuums are often overfilled in such tests as well, causing undue failure and misleading further. A big mess test does not illustrate deep cleaning ability, or in fact, anything meaningful about a vacuum. If you see such a test being used to illustrate anything about performance, particularly in reviews, and not treated as pure visual entertainment, then this illustrates a complete lack of understanding of how vacuum cleaners work, and such nonsense should be called out. An agitation test puts particles that respond to vibration, such as sand, into a carpet, and shows them being vibrated around near the head. This test is highly misleading for several reasons outlined in a dedicated video, with the first link in the description. Briefly, the concentration of sand used is unrealistically high, with all the problems that brings as mentioned earlier. It ignores that other particles that are more dangerous to health, such as microscopic dust, don't bounce and are unaffected by agitation. Excessive agitation also produces excessive noise. Agitation outside the cleaner head region isn't important because bouncing and wandering particles aren't removed unless the cleaner head is over them. Deep cleaning can be achieved with considerably less agitation, and the highest holistically performing cleaners deep clean sand-like particles from the most important surface layers without overly aggressive and noisy vibration. If you see reviews implying that a vacuum is a better cleaner because of a high level of aggressive vibration, it illustrates a lack of understanding of the true purpose of agitation, namely to ensure particles are freed for removal by high airspeed through the pile. The most important takeaway messages from this video are: deep cleaning is a term that is widely misunderstood and misused. Correctly used, it should refer to cleaning the upper region of a carpet as well as possible. dust in the surface region can be re-released back into the air. Real-world, normal household levels of dirt don't readily penetrate beneath the surface region, and little dirt will likely be present near the carpet base with normal carpet care. Deeper dirt isn't released back into the air. Sand at depth is trapped and doesn't move relative to the carpet, and therefore doesn't abrade, unlike sand at the surface, which can be scrubbed across a carpet, causing sandpaper-like abrasion. Good modern cleaners can clean real-world dirt levels from the base of a carpet, and brute force machines can actually dirty a carpet by bringing harmful dirt from the concrete floor. Overpowered machines can clean unrealistically excessive messes faster, but don't necessarily therefore achieve better final cleaning results due to statistical processes and many other factors involved. All good vacuums, including industry-leading cordless cleaners, can achieve similarly fast results for big spot messes. Many of the tests on the internet which try to indicate vacuum performance are flawed and misleading, demonstrating a serious lack of understanding of how vacuums work and microscopic cleaning processes. The only metric that's relevant to judging a vacuum's cleaning performance is the average cleaning performance across all floor types as measured by international industry standard fair and comparative testing. Thanks for watching, and I'd recommend rewatching it a second time.